Imagine the face of nature restrained by monochrome. Now see it in all its glory, dignity, inspiration. Not a world in black and white, but everywhere the multicolor face of nature. Color. It can entertain. Color. It can even save your life. RCA in 1951 successfully demonstrated to the FCC a 16-inch compatible color TV tube, and in 1953 put the 15-inch tube into commercial production. Today at the David Sarnoff Research Center in Princeton, New Jersey, color TV research begun in 1930 continues on phosphors, keys to brilliant color pictures on your TV screen. On new techniques for TV screens, looking for improvement inherent in RCA's total investment of over $130 billion in color TV. The quest embraces new magic for the electron gun. Modern science keeps pioneering for the benefit of modern manufacturing. Today, from modern RCA plants, this one in Lancaster, Pennsylvania, flow round and rectangular color TV picture tubes in volume production. The surging total is well over 1 million units a year. Another plant in Marion, Indiana, shares in this remarkable production achievement. What's behind this achievement? On the 21-inch round tube, the 25-inch and 19-inch rectangulars. Suppose you look and see. First at light-emitting phosphors, green, blue, red. The primary colors that come alive in your color TV picture tube. Here's how. From the triple beam electron gun, electrons flow to the shadow mask where they pass through tiny apertures and excite the trios of color phosphor dots to paint your color TV picture. There are 4 major tube parts: face panel, shadow mask, funnel, electron gun assembly. To make the shadow masks, thin steel is first coated on both sides with a light-sensitive emulsion. Aperture pattern is printed and developed on each side. The pattern of the aperture is etched out. The masks are removed from the roll. There are over 330,000 apertures in each 21-inch round shadow mask. Each mask is inspected for perfection of apertures. The mask is further measured for proper hole diameter, about 1/10,000th of an inch in the 21-inch round mask. Visual inspection, silhouette of craftsmanship. Cross-section of an aperture greatly enlarged. Aperture shape and diameter are critically controlled. Production flows on. The shadow mask cannot remain flat. It must be shaped to its proper contour. Here for the rectangular 25-inch tube. Typical investment in machine power, personnel power. The masks go on their way to be welded to the mask's frame by a unique indexing machine. The goal, as in all operations, is perfect uniformity and top quality. The road to quality has many checkpoints, including this critical contour check. Green is go. To the next main tube component, the face panel. First, incoming inspection for the face panel, on which you actually see the color TV picture. This equipment verifies the panel's seal edge at many points, automatically, precisely. Then the contour of the picture surface is checked at more than 100 locations. The glass face is also examined for optical blemishes. Any scratch or distortion means rejection. Certified. On to screening, where the shadow mask and face panel are joined, and where the 3 color screens are applied. The panel is washed, TV dot clean, to receive over 1 million precisely positioned dots of phosphor colors. The first phosphor is applied. Here, where many steps merge into one, a color career is being born. The material is called phosphor slurry. Every aspect of this deposit, weight, composition, volume, is rigidly controlled. The procedure for the round tubes is duplicated for the rectangulars. Here is the application, too, of color TV research dating back to 1930, and tube technology refined through the making of millions of many kinds of tubes. The shadow mask is oriented into the face panel. Next, the first phosphor dot will be positioned by exposing the sensitized phosphor to an intense light beam which passes through each aperture at the same precise angle as will the color electron beam. This is accomplished on the lighthouse. The unexposed material is washed out, leaving a dot pattern. The phosphor dots are scrutinized for size, shape, uniformity of light emission. The operations are repeated 2 more times until, for each aperture, a trio of dots is formed. To provide a brighter color picture, the new phosphor dots are first covered with a film of acrylic resin and then a thin vaporized coating of pure aluminum. Shadow mask and face panel are made a permanent assembly. Mask and dot trios locked in proper alignment. A tube sub-assembly is completed. The funnel, third major part of the tube, gets its own rigorous incoming quality inspection. These tests include mechanical dimensions, alignment of neck and funnel, quality and thickness of glass, trueness of mating surface. Now, at many peripheral points, the funnel is questioned. It must have the right answers or it cannot pass this border. On its journey to your home, following a thorough wash, the neck of the funnel is ringed inside with a red, high-resistance film. Next, a highly conductive black coating. The balance of the interior of the funnel is sprayed with its conductive coat of black. The 2 major glass assemblies, the coated funnel and the screened face panel, are now ready to be joined. The bond starts with a sealant called frit. This special sealing glass is dispensed to the mating surface of the funnel. At the bulb seal oven, the face panel mating surfaces are cleaned and prepared for sealing to the waiting funnels. Fixtures hold the parts in rigid alignment for the several-hour passage through the oven. Under intense heat, the frit sealant crystallizes, forming a vacuum-tight, high-strength bond. Electron gun manufacturing, as with all tube parts, begins with material control, where all incoming materials are tested with extraordinary care. Take cathode nickel, for example. A sample is dimensionally checked and identified for further laboratory analysis. In the chemical and physical laboratories, the sample undergoes spectrographic analysis, verifying the exact composition and degree of concentration of all metals present. Another guardian of performance, the test to determine if carbon and sulfur are within specifications. Nickel samples are polished for examination for crystal structure. The electron probe analyzer will identify inclusions as a final check on perfection of material for the triple electron gun. Now highlights of the gun's making. First of its sub-assemblies, the partial gun. The merry-go-round, where components of the partial gun are loaded into precision fixtures and mandrels. Close tolerance design and manufacturing experience are segments of the circle. Working skills learned through generations of tubes complete the circle of quality. Another circle, bonding glass and metal. Fire to lock the partial gun components into one rigid permanent structure. Inspection is continuous. Aperture alignment, part spacing, and angular gun tilt are verified. Convergence cage parts, another important triple gun sub-assembly. Its parts are made of special magnetic material. They are assembled to extremely close tolerances. The stem, to which the partial gun and convergence assemblies are mounted. An old and respected art here, stem making, carried to new heights of perfection by RCA's depth of experience in bonding glass and metal. Final assembly of the triple electron gun is completed in a pressurized clean room. First, the heart of the gun, the cathode. In this special chamber of the clean room, it is sprayed with its emissive coating. Jewels being selected, heaters being inspected. They must glow in performance. To keep high performance level, never ceasing vigilance. In the capacitance inspection, assemblies are electrically checked for mechanical dimensions to ensure that every specification is met. Once more, the partial gun is checked for alignment and cathode coating. Another quality checkpoint to assure good performance and long tube life. Gun mount assembly in the pressurized clean room. Care, extreme cleanliness, and the delicate touch for precision components. All parts of the triple electron gun now become one. Convergence cage, gun, and stem are first jigged, then welded into an integral unit. Final inspection for the complete gun, including a check of more than 150 welds. It's a manufacturing responsibility, and it's an exacting examination. But it's not enough. Quality control inspection, independent of production. This exemplifies the overall RCA pattern, insistence on quality of product and performance. The triple electron gun now becomes a permanent part of the tube. In this glass sealing operation, there is heritage at every turn. Receiving their gun assemblies are both the round assemblies and the rectangular assemblies. The sealing flames, bringing the triple electron gun closer to its dynamic role in the color TV picture tube. Each assembly now becomes a color picture tube by being processed in this straight line exhaust machine. The oncoming cart, a complete pumping unit, will carry the tube through the oven, where high temperatures will drive contaminating gases from the glass and metal parts, while the tube is being pumped down to a near perfect vacuum. During this process, the cathode is also activated, and the stem tubulation is sealed. The tube is given its base, and the getter is flashed. It goes on to the aging conveyor en route to testing. In the dark, the light of factory testing. For every single tube, demagnetizing starts a series of critical production tests for purity of color, convergence, focus, resolution, light output efficiency, electrical characteristics, and for top performance under black and white and color signals. In addition, quality control makes a continuous sampling test on a daily basis to assure the product meets all specifications. Application lab engineers cross-examine sample production tubes in actual TV receivers for performance compatibility. Unique equipment, special inquiry. The tube is tested in a controlled magnetic field. The electrical characteristics of sample tubes are evaluated on a special engineering recorded reading test set. A permanent record is maintained of all significant criteria of performance. Important, the tube's ability to reproduce color and black and white with equal quality and fidelity. Sample tubes are subjected to long-term life tests, monitored for their stability of characteristics during a thorough series of investigations. In addition, larger samples from each day's production are subject to short-term operation and evaluation by PRAM, which means Performance, Reliability, Assurance Monitoring. Constant vigil on quality. Nearing the end of several hundred major operations and coming to conveyor's end. The last production electrical test and visual inspection before packaging. But each production lot is retained in shipping for a predetermined time, and then a quality control sample must once more satisfy demanding production standards. Only then is the production lot released to manufacturers of color TV receivers. In progressive TV set manufacturing plants, each tube becomes the heart of a great achievement, the compatible color TV receiver. RCA's progress in color TV since 1930 in research, materials, product design and development, and manufacturing has created new opportunities at home and abroad with tubes of known quality and performance. The 21-inch, 25-inch, and 19-inch. These are the tubes that bring to your home the beautiful world of color.